Hello.
Hello, sir.
Hi, sorry you can't see me. It's too bright in here.
Hi. Yeah. So,
How are you?
yeah, it's good.
How's the presentation going?
Uh, I I can share you the uh, link.
Okay, go. We go through it. So I can, of course, not give you detailed uh, things like do this, change that, etc. Because it is your presentation. It has to reflect your work.
Yeah.
But we can, of course, discuss the broad strokes of it.
This one. Yeah. So now I'm considering to, like, there is a motivation and an introduction. I may combine them to one slide,
Mhm.
and then the research aim. Then I will go through the data I use in this project, and the pipelines, give the audience a overall structure of the project. Um, Here's the ingredients. Then combine the ingredients with the sunspot number.
Mhm.
Yeah, and
And yeah,
yeah,
so for these things, you should always say why we are doing that. And we are doing that here, for example, because there is a simple model for like sunspot number, right? There is a simple this parametric model
yeah,
that is from the 60s or something.
yeah.
So you should say that, right? Our goal in the end, so this is it's probably going to the motivation,
Mm-hmm.
is that we want to model these effects in simulations.
Yeah,
Right? So the big picture, the logic about this is there are solar flares, they go to bits, the images get worse. So to model this, we need to know all of these things. We need to know how many solar flares are there, how do we model solar flares,
mm-hmm.
and then how do we model the impact on the images.
Yeah,
And so we have this distribution, which is correlated with the solar spots, which you show here, and there are simple models for like the sunspot number. So we can build our model like this.
yeah. So I should put this in the introduction part or the.
Yes, I think somewhere in there you want to say, right, that so what is the actual physics here? The physics is there are solar flares create X-rays and protons. We ignore the protons, we just focus on the X-rays,
Yeah,
and that makes the images worse. And then the next question is, okay, if we want to model this,
yeah,
we need to account for both of these things. We need to account for the solar flares, and we need to account for the impact on the images. Right? So that's the logic of the whole project.
yeah.
There's the physics bit, which is what happens in real life, and then there is how do we model this.
Mm-hmm.
And these are the two things that you have done. You found a way to model the solar flares,
Yeah.
and you found a way to model the impact on the images.
Mm-hmm.
Right? But so the basic motivation, the thing that people need to know to understand your project is the physics first. Right? So solar flares happen, puts out a lot of X-rays, puts out a lot of protons. The X-rays make the images worse, and you can show this from the paper because I think it doesn't leave the room.
Yeah.
There's this image in the back where you see what happens. It's also in the Okay, I will send you a link 1 second. Let me just find it very quickly.
Yeah.
So there is a picture that you can use from this paper. And you just have to attribute it because it's not your picture. So you know how to do that, right? You say it's just an image credit, and then you write this. 1 second, where is the best place to write this? I'll just write it here in the chat. You can see this. So there is this paper. It's called Euclid 1. It's just in the Zoom chat. And then if you look at figure 21.
21.
So you pages down. You see figure 21.
Yeah.
So there you see this artifact, right? This structure in the image.
Yeah.
That is caused by the X-ray. That's how the X-rays make the images worse.
Yeah.
And this happens because there is a gap in the sun shields, unfortunately, in Euclid, where the X-rays can go through. So you can say that there is it's written there in the description of the figure. So you can just show this figure to show people what happens, really. Right? And then you say, okay, right, this is the physics is this. This is the motivation for this. Solar activity causes X-rays. X-rays make pictures worse.
Yeah.
And then, okay, now if we want to model this, we need to model both of these things. We need to model the X-rays coming out of the sun, and we need to model how they make the pictures worse. And you have done both things, right?
Yeah.
Yeah. So this is really the high level thing. So it's good for you to say this explicitly so that people really understand what's going on in real life and that you're trying to capture these two things.
Yeah.
Okay. And then, so, right, why do we do the things that you showed on slide 7, for example, right? We do this because we want to know how much X-ray flux there is.
Yeah.
For a given thing, right? Because we need to know this so that we can model it. Right? Then it all makes sense for people who listen to this. And you say, of course, yeah, right? We need to know how much X-ray flux comes out so we can measure the impact on the images. And then you have to explain that, okay, and then right, if we want to predict this, there is a proxy for the X-ray for the amount of solar activity which is in the sunspot. And you have this nice plot which shows that they correspond to each other, that there's a strong correlation. And then you can say, right, there are simple models for the sunspot number, which is the thing in the paper draft that you have, where they show at the beginning. It's this sinusoidal pattern, right? It's very regular, the solar activity.
Yeah.
So from this, you have a good model in the end of the solar activity. And then once you have that, then okay, now we have the model for the sun part of this, the solar part of this. Now we need to model the impact on the observations. And there you have done this other stuff. Okay, and let's get to that.
Yeah, and then I haven't decided what to explain in this part. But I think I need this part to like tell the audience what is the
Yes. So I think here you can just go back to the same figure 21. So you can use it twice, same figure.
Yeah.
And you can say that here is an image of what happens when there are X-rays, right? And this was for an M-class solar flare. And you see how much of the image is not usable, right? Because there are too many. It's called cosmics. There's this part of the image which is not usable, right? And then you can say, okay, and how much is not usable depends on the strength of the solar flare. If they are very faint, then they get shielded. If they're very strong, then they make a much bigger impact. And then it depends on how long do the solar flares last, because that depends how many images are affected, right? And then you can show, I think what is on plot 12 is the first thing that I would show, because it's exactly these two things on top of each other. So if you look at your slide 12, right?
This one.
Yeah, this is exactly this. So you have quantified this.
Yeah.
You can start with the image saying this is what happens during an M-class flare, during a low M-class flare. It says that in the figure caption.
Mm-hmm.
And then you have looked at, okay, what happens to the images, how many pixels are lost as a function of solar flare strength.
Mm-hmm.
And you get this plot. And then you should also explain what the color means, right? The overlap fraction. So here the whole yellow is the whole exposure is lost, and blue means that is that the whole exposure overlaps with the flare, and the blue ones are where it overlaps less with the flare.
Yeah.
Just in terms of duration. And then you see it, and you can already see here from this figure where you have just put a dot for everything, for every single event, that there is a trend. Exactly.
Yeah. So I need to put this one like.
I think that makes it clearer.
Yeah.
Because you can immediately link it to the image before.
Mm-hmm.
You can show people the image of this is what it looks like. And you can see there is a solar flare happening.
Yeah.
And then there are regions of the image which are more affected and less affected.
Mm-hmm.
So if we want to simulate this, we need to know how big is the effect. Yeah. So you have gone and you have mapped every single solar flare for Euclid VR1, so in the first year of Euclid.
Mm-hmm.
You have for every single solar flare, taking into account the 504 second delay, how much of the image is lost.
Yeah.
Right? And then you start, okay, so we see this, there is a trend, and then I've started to do the binning, you can say, right? Mm-hmm. And then you've done the fitting, and you have found this quite neat model for it.
Yeah.
Yes, and then you're already done with your 12 minutes, basically.
Yeah, I think so.
Yeah. Yes, and then, right, so you can show the next slides, which are very good. Right, so this is just the bin version of this.
Yeah, bin version, and then the...
Yes, and then you can say, I binned this, and then you can see quite clearly the trend.
Yeah.
And then you have fitted this as well with the function, and you can explain that how you got to this function a bit, but you don't need to waste too much time. I think the pictures tell a very nice story here.
Yeah.
Yes, and then you're basically at the end.
Yeah.
Then you can say that now you should put in definitely something about still to do, like future work or whatever you want to call it.
Yeah.
So where you say something like, right, so now we need to put all of this together to make a consistent model.
Future work.
Yeah, so you want to make this into, I mean, maybe we will not get to it in the time of this thing, but right, you want to make a model where you get a solar flare from your distribution.
Yeah.
And for the solar flare, you say how much it affects the observation. So you want to put all of this together into a consistent model from start to finish.
Yeah.
But this is maybe something that will happen after the project, but this is very useful for Euclid itself. So this work will be picked up and will be used for modeling things.
Yeah.
But yeah, you should claim this. You should say that this is the end goal of this. The end goal of the project is to have a full modeling of the impact of solar flares, where you can do this whole thing, right? You predict the solar flares and you predict how much they degrade the images. Then you can make masks or something like this, or you can talk a bit about why this is useful to understand how much survey area is lost, etc. to simulate this.
Yeah.
Yes, and then you should definitely have another slide at the very end with your conclusion.
Yeah, sure, I will do that.
Yeah, where you say, right, that you have to model the solar activity, and you have model the impact on Euclid, and you can fit this, and we can predict for a given class of solar flare how much pixels we lose in the observations, etc. So just all the things that you have done.
Yeah.
And then there will be a couple of questions. I think I would probably also put in at least one bonus slide. So slide at the end that you don't really show unless someone asks a question. Because there is one thing here that you have not said in your presentation, and that is that there are low intensity, low solar activity years and high solar activity years.
Oh, yeah.
Yeah, so someone could ask about that.
Mm-hmm.
So maybe you want to have somewhere on a hidden slide at the end, like a bonus slide, we always call it, where you show the different distributions, right? So the distribution you have that you fit at the beginning, that is for one specific year.
Yeah, this one.
No, before that.
Oh, this one.
Yeah. So this was for all years together.
Yeah.
Yeah. But of course, you had these other distributions of events per energy, where you could see the difference between high energy year, high activity year, and low activity year. You remember the histograms that were moving left and right?
Yeah. I remember that.
Yeah. So maybe I would even put this in here slightly before that, just to. So I don't know. It depends on how much time you have, but I would definitely put this somewhere, because if someone asks a question about, how does this picture change when there is high solar activity versus low solar activity, then you can show this extra plot where you have looked at both things and you see the difference in the distribution.
Yeah.
Does that make sense?
Yeah, it makes sense. So
yeah, you kind of want to anticipate a bit the questions that people could ask you.
Yeah, maybe I will put a slide before this one, maybe.
Yeah, I think it would be nice, but you have to be careful with the time.
Yeah, now I already have 14 slides.
Mm-hmm. Yes. So, I mean, this is your job for this week.
Yeah.
Right, to editorialize a bit and see what you need. If you can make it right, you can also put two images on one slide, for example. So you could put all the years on top of this at the top, right? And then you can say this is the distribution for various years.
Yeah.
And then you can show at the bottom, right? And here is how I try to fit them with various means. And sometimes, it depends on the year how well this works. So
yeah,
this is.
Maybe I can just delete this part and put a figure in this part, in this area.
For the various years, yes. So I'm sure you will figure it out.
Yeah.
But yeah, you'll so then you can you can basically. So yeah, like I said last time, the most important thing is that in your head, the story is clear that you want to tell.
Yeah.
You always know why are you showing the next slide.
Yeah.
Right. So when you start, why am I showing this? Why am I saying this? From there, what is the step to the next slide? What is the step to the slide after? So that it should really be a story that makes sense.
Yeah.
Not just I've done all of these things, really, right? Here's the thing that happens in the real world. There's solar activity. Maybe you can find a nice picture of like a solar flare or something, right? And when that happens, on the left-hand side, you have a picture of a solar flare, and on the right-hand side, you can put the picture of Euclid, figure 21.
Yeah.
Right? So that people already know immediately, okay, right? Solar activity makes images bad. Right? And then, okay, and so if we want to predict this, we need to know what happens at the sun. We need to know what happens at the instrument.
Yeah.
Let's start with the sun. These are the years of solar activity, the number of sunspots or the intensity, the things that you have. And then we can try and model these. And you can talk a bit about the different classes, what they mean, right? C class, M class, whatever it is that you need to say. So once we have this for a given year, we can connect it to our proxy, which is the sunspot number, because we can predict the sunspot number for a given year.
Yeah.
So with that, we have done the sun bit. So now we go to the pixel bit. and then you can show the image again, right here in the next slide, and you say, right, so now we know that if there is a solar flare, this happens to the pixels.
Yeah.
This is for a low M-class solar flare. But the stronger the flare, the more we lose. Bam, next plot. Here's what this looks like. So here you've mapped all of these things and you explain how you put the points on this plot.
Mm-hmm.
And then you say, okay, well, here you can already see that there is a trend. So bam, next plot. I managed to print the trend.
Yeah.
Right? You have pinned this, and there the trend is very clearly visible. So with this, we know exactly, okay, if I have this and this strength of solar flare, this is how much pixels I lose. And then here, this looks very nice and smooth, so you can fit this. And here is what I've done. I fitted this, and I have this very nice prescription. And then, right, future work, we put these two things together, and then we have a model for everything. And then that's it. Thank you very much. So it is a story. It is everything you've done makes sense.
Yeah.
To do what you wanted to do.
Mm-hmm.
So this is a good project.
Yeah.
Cool.
Yeah.
Let's leave it at that. Are you happy? Do you know what to do?
Yeah. Thank you for the suggestion. I have a clear, like, overall of the presentation.
Okay.
Yeah.
I have to go to a department thing, unfortunately. But okay.
Yeah.
Yes. If you want, we can have another quick chat about it. If you feel like you want to do it on Thursday, maybe. But if not, I think you have it under control. So it's your choice. Just send me an email if you want to talk quickly.
Yeah, sure. Maybe when I finish the PowerPoint.
Okay, and otherwise, yeah, Friday. I'll see you Friday at the late.
Yeah, my presentation is Friday.
Yes, at 11, I think.
Yeah.
Okay. Good. So if you want to talk before Friday,
yeah,
just send me a quick email.
Yeah, sure. Thank you for the. Yeah.
No worries. Thank you for all the hard work. See you. Let me know when to see.
Yeah. All right. Bye.
Bye
Thank you,
now.
sir.